Okay, we have trig ratios and congruency. So here we notice a right-angled triangle. On the right-hand side is the one I'm looking at with the 5 meters. Notice we have to find x. Clearly, we cannot use Pythagoras to solve that. We will have to use a trig ratio because we are given an angle and a side. Therefore, we can find the missing side x. X is the opposite side of the 30-degree. So x is directly opposite to the 30-degree angle. 5 is the adjacent side. Trig ratio. Opposites over adjacents will give us what? 10. Right, we're going to need a calculator to solve this. Move the 5 over, we're going to get x is equal to 5, 10, 30 degrees. So 5 times 10, 30 equals. We now have x is equal to 2,87 meters. Next thing, we need to find y. So tan function again, using the tan, we're going to have opposite over adjacent. So that will be the x over the y. Now we have to manipulate the equation by moving y over to the other side. The opposite of divide by y is times y. Now we need to make y the subject of the formula. Notice that that is multiplication sign between the y and tan 30. So the opposite of times tan 30 will be divide by tan 30. Make y subject of the formula. Right, our answer is 4,97. Our answer didn't come out to 5 perfectly because we had rounded off to 2 decimal places in the previous line. So therefore, we're going to round off to the nearest whole number. Notice that both the triangles are exactly the same on the left and the right hand side. We can now find Z. Z is directly opposite the 90 degree. It is the longest side of the triangle, therefore the hypotenuse. Therefore, for Pythagoras theorem, we will add. We will add the 2 short sides, square them, square root it to get the answer to find Z. That will be Pythagoras theorem. Alright, punch that all into your calculator, get the answer for Z. Right, we now have the answer for Z, the longest side of the right angle triangle. Next thing, they want us to prove that the triangle on the left is congruent to the triangle on the right. We can see that AB is equal to BC, which is equal to 5. We can see that BD is the common side. We can also see that the two bottom angles will both be 90 degrees. So angle ABD is equal to DBC. They're both equal to 90 degrees. So the two angles are congruent based on side, angle, side. Another way it could have been done is to say angle is 90 and 90. Both angles are 90. We know that x is common to both triangles, and we know that the hypotenuse will both be z in both triangles, z on the left and z on the right. So we would have had right angle, hypotenuse, side. Right, x would be the side, the 90 degree will be the right angle, and z would be the hypotenuse. So we'll have RHS, right angle, hypotenuse, side. That was the other way we could have proved them congruent.